Okay, so we're going to do the lesson kind of like how we did last lesson, where I'm just going to kind of go over the PowerPoint with you guys and then do a couple of examples from your homework. Yesterday we learned about the synthesis and decomposition reactions. Today we're just learning single replacement reactions. It's pretty involved, so we're just doing this one alone, and then tomorrow we'll do decomposition and combustion reactions. But after today, I want us to be able to identify single replacement reaction and predict the product. So given the reactants, I want us to be able to say what will be produced in that reaction. So a single replacement is just when an element and a compound react to form different element and compounds. So basically, you're going to take this element and a compound, and if the reaction occurs, then you're going to have a different compound. So basically, A will take the place of B, and then you have a different compound and a different element. This is the only one where you have to decide whether or not the reaction occurs. All the others, we're just going to assume it does. But with this one, it doesn't always occur. We have to use the activity series sheet, which is just a piece of paper that you will have available to you during the test, and you will have available to you during your homework. They're going to be up in the front with the periodic tables if you want to have access to them. Basically, like will replace like. So basically, for most of these problems, metals will replace metal. There is a type of problem where the nonmetal replaces the nonmetal, and we'll do an example of that at the end of this lesson. Okay, so our first example is we're looking at lithium. What would happen if we combine lithium with zinc acetate? Basically, I like to decide where my metals are and nonmetals. Okay, so lithium is a metal, zinc is a metal, acetate is a nonmetal polyatomic ion. So we're basically just trying to find out, will lithium replace zinc in this compound and become lithium acetate plus zinc? So in order to find out if this will occur, we have to look at the activity series sheet. And that's this thing. You're going to have this in paper form. But you're going to find the two ions, the two metal ions, and decide whoever's on top. So this may sound silly, but I call this this reaction the Mr. Steal Your Girl reaction. So if like the metals on top are the most reactive, or you can picture them as the most attractive guy, and whoever is the most attractive or reactive will take the place of all of these other metals. So lithium is actually the most attractive or the most reactive, so he will always take the place, or this element will always take the place of all of these under here. So the products will actually be zinc will be alone now, plus lithium acetate. So lithium is more reactive than zinc. And that's all we're doing with the single replacement. We're taking a look at our reactants and seeing, will the metal that's alone, is it reactive enough to take the place of this metal that's already bonded with something? And that's the products we're going to have over here. Okay, so we're going to do a couple of examples, and then I'm going to show you the non-metal, and then I'm going to move over to our homework and do a few examples of those. So copper mixed with aluminum sulfate. So copper and aluminum are the metals. The sulfate is the non-metal, and we need to look at our activity series sheet to determine, is copper going to take the place of aluminum? So let's look. So aluminum is up here, and copper is down here. So copper is actually pretty low on the reactivity list, so he's probably not going to be able to take the place of aluminum, so no reaction will happen. So if whatever is thinking about taking the non-metal, taking the metal's place to be with the non-metal, if it's not higher than this one, then it's not going to react. Why would you get rid of somebody who's really great for someone who's not so great? I don't know. So copper is lower, so it's not going to replace aluminum. So another example, we have lead carbonate plus barium. So lead and barium are both metals, and we're going to see if barium is higher than lead. If barium is higher than lead, it will replace lead and become part of the compound, and lead will be alone. So barium is pretty high on the list of the activity series of metals, and lead will be down here. So yeah, barium will definitely take the place of lead, and it will become barium carbonate plus lead. Keep in mind, you do not need to bring over this Roman numeral. The charge doesn't matter. You just know this is lead metal. Sorry, no Roman numeral necessary. Okay, another example is when you have acids. Acids undergo this type of single replacement. So when you have sodium plus water, okay, water is, we know water is H2O, okay. So I would write it hydrogen hydroxide, okay? I would write the hydrogen here. So because that way you know that hydrogen will be the one that's possibly replaced, okay? So we're going to see if sodium will replace hydrogen to be in a compound with hydroxide. So basically, we're going to compare sodium to hydrogen, and the tip here, I'm sorry, I got distracted with it. It just rolls and rolls. So I would change hydrogen hydroxide here instead of just water. If you know it's, H2O, and the hydrogen is going to be one of the ones that are replaced, go for it. But when we go on to do acids, I always put the hydrogen in front of it no matter what the acid is called. I write hydrogen and then it's polyatomic ion that it's combined to. It just makes it easier to say, okay, I know I'm comparing sodium to hydrogen. Okay, so hydrogen's pretty low on the list. Basically, the only ones that won't be able to replace hydrogen would be copper, mercury, or silver. So everyone else will replace hydrogen. Sodium is not an exception. So the new compound will be sodium hydroxide, okay, plus hydrogen. Hydrogen is now alone. Okay, acid now. Now we're talking about acid. It is replaced by a more active metal. So remember, guys, I showed you the three metals. Basically, if it's not one of those three, it's going to be replaced. So here's an example of calcium plus phosphoric acid. So I would rewrite this to have the hydrogen in front and then your ion next to it. So for example, this is hydrogen phosphate. I would just switch that to have your hydrogen here, so you know you're comparing this to this. To me, that's easier. That way you know whenever, because you wouldn't put phosphoric calcium or something. It just makes it easier to rename over here if you break it down from hydrogen to whatever ion it's combined with. And you're going to have to recall information from last unit. So remember with the acids, if it ends in IC, then it is one type of ending. If it ends in ic, ate, or ite, okay? So make sure to review your naming acid rules. So in this case, if the ending ends in ic, the original ending was ate. So that's how you would find out what your other ion name is. Okay, so comparing calcium and hydrogen, hydrogen's all the way down here. Remember, only these three will not be able to replace hydrogen. Calcium's up here, so it will be replaced. So it will be calcium phosphate plus hydrogen. Okay, non-metal. So here's an example of a non-metal replacing a non-metal, and we do have it does have its own section on your activity series sheet, so don't worry. You won't have to memorize these, I don't think. Okay, so we're looking at fluorine, which is a nonmetal. So that gives it away right there that this is a nonmetal compared to nonmetal. So I see fluorine, it's not a metal, right? It's on the very far right of the periodic table. It's a nonmetal. So you will be seeing a fluorine. We're not comparing it to the metal. Sorry, I'm boring myself. We're not comparing it to the metal, we're comparing it to the non-metal, okay? So fluorine and iodine is what we're comparing, okay? The two non-metals. So there's only 4, so that's easy. Fluorine is like the lithium of the non-metals. It's very reactive. And iodine is the least reactive. So basically, anytime you see fluorine over here, it's going to steal the iodide's place, and iodine will be on the other side alone. like this. Okay, so watch your endings. Make sure you fix those endings. So don't put magnesium fluorine plus iodine. Make sure you take away the "ide" and put INE. Just watch that. That's one of the mistakes I do see in the test whenever kids try to write their endings. Okay, now I would like to do a couple of homework problems with you. So if you get stuck, you can see how I would have done it. I'm just going to do maybe 1 or 2 or 3 of these problems to whatever. Let's start. Okay, so we're looking at this is single replacement. So I have a metal and then another metal and then a non-metal. Okay, so all single replacement is will this metal replace this metal? And to find that out, I have a activity series sheet. Okay, so we're looking at the activity series sheet. That is polyatomic ion, sorry, but this is activity series sheet. So just make sure you memorize this by the next test. I'm just kidding. We're going to look at this and find out whether or not this will replace this. So we have calcium trying to move in on magnesium spot. Here's calcium here, and magnesium is down here. So no, calcium is the one trying to move in. Yeah, so calcium is going to take its spot. So we're going to have calcium sulfide plus magnesium is now alone. Step up his game. Okay. All right. So we're going to, I think the others are pretty the same. Number 7, I want to go to number 7 because it's unique. But basically all of these will be done in this way. You'll just look at the activity series sheet. Number 7, we're going to see if, so this has an acid in it. So sulfuric acid, I'm sorry. So sulfuric acid, I would rewrite it, hydrogen, okay. All right, so we're looking to decide whether hydrogen and silver will change places with the acid. So we have silver somewhere. Silver is all the way down here, okay, and hydrogen is up here. So the reaction's not going to take place. So when that happens, just write no reaction, okay. And then I would like to do one with non-metal, metal. Here's a non-metal one. Okay, so you notice that the one that's alone is a non-metal. So this is non-metal, this is metal, and this is non-metal. So when the one that's alone is a non-metal, we have to compare it with the non-metal, not the metal, and decide whether or not it's going to take its place. So we have fluorine and bromine that we're going to look at. So that's metals. So these are all metals, and then these are the non-metals. Fluorine's at the very top, so it's basically going to replace everyone, but bromine is right here. So it will replace it. So instead of gallium bromide, it'll be gallium fluoride. Don't forget to change the endings, okay? Plus bromine, okay? So that's really where all the points come off. I mean, this stuff is pretty easy and straightforward. You're just switching places. The worst mistake you can do is, actually there's 2 on this one. The kids usually either forget to change the endings, or they try to compare fluorine with gallium and get super confused when they can't find gallium here, or they can't find fluorine here. So just kind of check who's alone. Is it a metal? It's going to try to replace a metal. If it's a non-metal, it's going to try to replace a non-metal. That's it. I've done one of every example. So yeah.